Hi everyone. We have the third class for permutation and combination. I keep saying we need to exhaust factorial before we start permutation and combination. All right. Today's class is a very important and of course it's very interesting. Let us come and see how we write n factorial. We already know that 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 7, 6, 5, 4, 3, 2, 1. Two conditions. One, successive multiplication without missing a number. Successive what? Multiplication of consecutive numbers. But the second condition is that it has to be backward until you get to 1. So this is the expression for what? 7 factorial. But the thing is, how can we write n factorial? Owing to the fact that we need to write the numbers consecutively, multiplication, backwardly until we get to 1. How can we produce 1 with n factorial? Then how can we do it? If you understand what we are coming to do today, then you stand a chance to understand better the whole topic of permutation and combination, including the factorial itself. Okay. Now, we need to establish a technique here. Otherwise, we cannot write n factorial. Do not forget that the factorial number is always positive. The factorial number is what? Is always positive. It can be 0 or more. So it means the factorial number has to be greater than or equal to 0. Okay. Now, it depends the author. It depends the teacher. It could be x factorial. X factorial is the same as n factorial. Yeah, is the same as p. So if you can expand or you can give the expression for n factorial, then it is the same for this, is the same for this. Now let's pay attention. Now, we want to write n factorial, but we already know how to write 7 factorial, 8 factorial, 9 factorial. Now let us see. For us to write the n factorial, let us establish a great point here. 7 times 6 times 5. Do you know that 4 times 3 can also be written as this way? If yes, then we can write this one as 7 times 6 times 5 times 4 times 3 times 2 times 1. You stop at 1. Okay. Now, if this and this they are the same, I think we are one step ahead. Now, what is the next? How do you compare 1 with 6? How do you compare 7 with 6? How do you compare 7 with 5, 7 with 4, 7 and the rest of them? Let's see. Now, what we say is that 6. Do you agree that 6 is the same as 7 minus 1? You agree with me? 6 is the same as what? 7 minus 1. It is 6. How about 5? 5 is the same as 7 minus 2. 5 is the same as 7 minus 2. How about 4? 4 is the same as 7 minus 3. Yeah, the factorial number is the one you are using. How about 2? 2 is the same as, we come here now. 7 minus 4. How about 2? Is the same as 7 minus 5. How about 1? Is the same as 7 minus what? 6. Can we say 7 minus 7? No, we cannot say that. Why we cannot say 7 minus 7? Because 7 minus 7 will give us 0. And once it is 0, 0 multiplied by anything else is 0. So it will destroy this factorial number. I just hope you get the point here. Now, with this format we have, We want to write what? N factorial, which is now very, very easy. This is 7 factorial. This is another way of writing this. This is another way of writing this. So it means this is also 7 factorial. This is also what? 7 factorial. Now it is the time to write what? N factorial. Now let us see the logic here. 7 factorial, 7 starts, 7 starts, 7 starts, 7 starts everywhere. So that simply tells you that if it's also n factorial, we say what? N is outside. 7 factorial, 7 outside. N factorial, n outside. In the bracket, this 7 starts. So the same thing, n minus 1. The same 7 here minus 2. So we also say what? N minus 2. 7 minus 3. We also say what? N minus 3. But if you are a good observer, you will notice that because of this one is a numerical value, a known value, we know the end. Huh? It is a must that the end is what? 1. Now, 7 minus 6 is 1. But by the look of things, n minus 1, 7 minus 1, 7 minus 2, n minus 2. But by the look of things, n is not a known value. So it means we cannot physically see the 1. We cannot practically see the end of 1. But mathematically, the end is 1. So therefore, we say like this, 3 times 2 times 1. I hope this one is clear. Mathematically, a factorial number ends where? With 1. So even if you have a letter, you need to understand that it is a must for the last number to be 1. So therefore, n factorial is equal to n multiplied by n minus 1, n minus 2, n minus 3. I choose to stop here. You can choose to say what? N minus 4 until you get tired, blah, blah, blah. Then what? 3 times 2 times 1. Your colleague can choose to see what? N multiplied by n minus 1. So therefore, this can also, remember, in the previous video I said, 6 factorial is the same as 6 times 5, 4, 3, 2, 1. But I also told you in the previous video that 6 factorial can also be written as 6 times 5. If I get tired, I can stop here. The only thing is there must be a factorial. Maybe student B can say, no, I don't even want to get to 6. I'll just say 6 times 5. Yeah. Student C can say, no, me, I like writing more. Let me say 6 times 5 times 4 times 3. I stop here. The most important thing is if you don't get to 1, indicate the factorial. So the same thing goes here. N factorial can also be written as n into n minus 1, n minus 2. I want to stop here. No problem. Just indicate the factorial. Another student will tell that, no, me, I like it when I write more. N minus 2. Yeah, n minus 3. N minus 4. As long as you don't get to 1, just say what? Factorial. This one is very much important. So thank you for watching. Do not forget to follow, like, share, and comment. This is what I have for you for lesson 3. See you in my next video.